Hi everyone, I'm really sorry that I can't be with you in our lesson today. I've been doing something in the Easter holidays called jury service, which, if you can vote in the UK, you can randomly get selected to sit on a jury to help make a decision in a court case about whether someone's guilty or not guilty. So that's what I'm up to, that's why I'm not there. Hopefully I'll be back after today, I'm fingers crossed. But I didn't want us to get behind with what we've got to cover. So I've prepared a video for you on critical path analysis, which is the next chapter. It's the final chapter from D1 that we need to cover this year. So it's good news. It's the last bit we need to look at. And this chapter is all about project management and how we can sort of efficiently move between activities and completing a project. This could be, for example, if we're looking to plan an event, or if we're looking to build something big and complicated like a house. It could be overseeing production of a car in a factory. We'll see loads of different examples of how this can be used from the textbook examples. And the way this part of decision maths works is we break down a project into the different activities and we define the interdependencies between those activities. We can represent those both in a table, which we'll be looking at today, and as a diagram, which we'll also be looking at today. A bit like some of the graphs and networks we've been looking at, but with some subtle differences. So yeah, we break the project down into activities. If we were making a car, for example, some activities could be putting an engine together, spray painting the exterior, installing the dashboard controls and sound system. And logically, as you can imagine, some of these activities have to take place before we can complete others because they're dependent on others being completed. So some of them take priority or precedence. So precedence is another word that means the priority of things and the order in which we need to complete things. And yeah, so if we were planning a project, we want to make sure that, certain things are completed before others, and how long certain pieces of the project take can define when we need to start completing them, and so on. So we're going to look at these tables. The first thing we're going to look at today is these dependency tables, or as they're called in the textbook, a precedence table. So precedence, remember, it means looking at the priority, the importance of the order of completing things. Here's an example of a precedence table on your screen over here. So let me make sure I've got my pen on so I can circle things. So we've got activities on the right hand side over here, and we're just calling those activities a letter, really to be succinct. You can see over here on the right hand side what each of the letters mean. So A, for example, means to build a wooden frame. B means to cut out fabric for the cushions, and so on. In your table, if there's just a dash in the box, it means there are no activities that need to be completed before this one. So for building the wooden frame and for cutting out the fabric for cushions, they can start at any time. We don't need to complete anything before these are completed. So these activities are going to be at the start of the process at which we're looking. If there is a letter in the box, however, it means that the activity C cannot be completed until B has been completed. So if we look at what C is to stitch and fill the cushions. Well, we have to cut out the fabric for the cushions before we can stitch them and fill them. It makes sense. So B is in that box telling us that activity B must be complete before we can do C. Same for D. D over here is attaching springs to the frame, and that cannot take place until we've built the frame itself. So that's why A is in that box. And so here we can kind of see what needs to be completed for each activity until we get to the end. Like what do we need to complete in what order to complete this project? So you need to know how to complete these precedence tables, how to fill them in, and how to interpret them as well. In this example, it says, given that activity E can only be completed once all other activities have been completed, complete the below precedence table. So it means that in order for E to be completed, A, B, C and D must all be completed, because it says all other activities must have been completed. But rather than writing A, B, C and D, this would be, we don't need to do this. We only need to write some of the letters. And that's because, for example, if I were to write C in there, in order to complete C, I must have completed B. So by saying that C is completed, you can infer that B is already complete. And if B is complete, then A must already be complete. So by writing C, because of the dependency that B must be completed before C and then A, I don't need to write them in the box, if that makes sense. But D is dependent on B, so D needs to go in there as well. So let me just write that C a bit more nicely. Okay, so C and D is what goes in the box. As a rule of thumb, what you can look for, or double check, what you need in that column of immediately preceding activities is you need all of the letters to be there. So you want an A, a B, a C and a D in there somewhere. So here, if I was trying to take a shortcut, I'd see that C and D aren't in my column already and they need to be, so I'm going to write C and D in there. Okay, let's go down a little bit. Next example. So why don't you try and pause here and see if you can fill in this one yourself. Try and test how well you've understood that. And I'll just go ahead and talk it through, assuming that you've had a little think. So activity G can only be completed once all other activities have been completed. So here, if I was taking my little shortcuts, I would see that A, B, C and E are already in my table. And in order to complete G, A to F must all be completed, so I need to list them all somewhere. So the letters that are missing would be D, I've got E, and I need F as well. So D and F are going to go in the box. This shortcut only works if you have the wording once all other activities have been completed. Sometimes it might say, you know, G might can only be completed once F is completed or something like this. Then obviously you would put the right letter. But if it says once all the other activities have been completed, you can just look down the column, see which letters are missing and write them in. Okay, so that's precedence tables. And the other thing we're going to get familiar with today is activity networks, which is just a different way of showing the same information. And this time in kind of a graph network type diagram that we've been looking at, but these are a little bit different to the ones we've been looking at before because we're looking at a different scenario, different uses for these diagrams than we've seen before. So in the activity networks that we're looking at in this chapter, the arcs and edges represent the activities. For example, if so this branch here is labelled A, so this means activity A is being completed on this branch. If that's cutting out the fabric for the cushions, that's what this branch means. If B is building the frame, that's what this branch means. And the nodes, therefore, are kind of markers of that activity being completed. So this node over here means that B has been completed. This node over here means that A has been completed at this point of the diagram. Okay, what else do we have to say on these? So they represent activities, represent with a letter. That we must have straight lines, so no curvy lines. Don't want to see any curved lines in your diagrams. Include arrows to define the direction. So these are important because in this chapter we'll be looking at activities that build on one another. So something needs to be completed before something else is completed. So the arrows are important. They show the direction of flow of the process. Nodes and vertices represent events, like I said, so that they represent the completion of an activity, and they're not numbered on this diagram. This diagram comes from an exam paper, so obviously they haven't labelled the nodes, but in the ones we'll be looking at and the ones in the textbook, they are labelled with a number. So say we start at 0, 1 gets completed first, so node 1 would be activity A is completed. Let's call this one 2. Node 2 would be activity B is completed, and so on. So we can number them. The first node is called the source node. Source node. Let me zoom in a little bit. And the last node is called the sink node. So the source node, how would you find it in the diagram? Well, it's the one where all the arrows are kind of coming away from it. So it's the very start of the process. And the sink is the node where all the activities are pointing into it, so it's where the process finishes. So where's the sink, where's the source? We've covered that. Yeah, the dotted lines and the bracketed numbers for now, ignore them. We'll look at those in the next sections of the chapter, but we're going to ignore those for now. Okay, so you need to know how to draw an activity network from a precedence table. If you are inking on your screen, this is really good because you might need to rub things out. So in the tips it says always use a pencil, and that's because we might have to move some of the arcs around a little bit to make the diagram work sometimes. So be prepared to rub things out and draw things back in. Only draw a node and number on it when you need to add an activity on. So I'll explain with this example. So if I draw on my source node 0 over here, I can see my first two activities are going to be A and B. Now they have no dependencies, so they can just happen. They can just come straight from the source. Now I'm not going to draw on any numbers or nodes at this point until I add the next activity. So that's what this bit means. It means, you know, I've drawn the arcs, but I've not numbered them or added any nodes yet. I'm only going to do that when I add an activity on. So if I look at the next activity, so I've drawn on A and B, I want to draw C on now. Well, that's dependent on A. So now I'm going to draw a node. I'm going to call it number 1 because I'm just follow the sequential numbering pattern. And off of this one, I'm going to have activity C. And D is also going to come off A as well because that's dependent on A. But that's a separate activity with a separate arc. So I'll draw on D. Now it says be prepared to swap edges around. That's going to become apparent in a second. Let me just do E first. So activity E is dependent on B. So I want to draw another arc, so I'm going to draw my node 2 to say this is where activity B finishes, and off of that I'm going to have activity E. Now activity F depends on C and E, so what I want here is I want this arc C and this arc E both going into a single node and coming off of that node representing completion of C and E is going to be the activity F. So what I can do is I could switch around D and C. So this is the tip, be prepared to swap edges around. We can do that to make this diagram kind of fit better. So if I put D here, and if I draw C here, and then I do a third node here, so C and E, once they've both been completed, and that's what node 3 means, I can complete activity F. So I'll draw an F. And then finally, activity G, that's dependent on D and F both being completed. So actually, if I just rub that out and draw F up here, I can draw on my 4th node, and coming off that, I'm going to have activity G. And when that's finished, the process is finished. So that's G done. And that is my activity network completed. Okay, and you need to be able to read off these diagrams as well as drawing them from a precedence table. You might also need to read off of them. Okay, what are the dependencies for activity F, for example? And if the question asked you this, we want to look at F, and you just want to look at the preceding node, what's feeding into that? Well, it's C and E. So, and that should tie in with what's in your precedence table, which is C and E. Okay, so yeah, I hope that makes sense because you have to be practicing that in a second. Right, so I've lost some text that should be on there, but basically this is we've got to draw an activity network from this precedence table as well. So why don't you try and pause here and have a go at drawing it yourself to see if you've understood. And I'm going to now talk through how to do that. Hopefully you've managed to have a look at that. So, right. I'm going to start off with activity A because there's no dependency for activity A, and it's the only activity I have that does not have any kind of dependency. So if I start with my source node 0, coming off of this is going to be activity A, and B, activity B is dependent on A. So once I've completed A, I'll draw the node there, B can be completed, and actually just looking down the table a little bit, I can see that C can also be completed once A is completed. So I'm actually going to draw B and C coming off of that node. D, that can happen when B has been completed. So I'll complete B and draw on D. Activity E, that can be completed once C is completed. So let's complete C and draw on E. F can be completed once E is completed. So let's complete E and draw F on. G can be completed once C is completed. So that's also coming off this third node where C is completed. Let's have G coming off there. Now H can be completed once D and F are completed. So I want the arc for D and the arc to F to be pointing inwards to a single node. So I'm just going to redraw this F over here. I'm going to have it coming up like this into a fifth node. So once D and F are completed, then I can complete H. I can be completed once G is completed. So let's have a sixth node, and let's have I coming off there. J can be completed once G is completed, so I need to move down a little bit and draw this one on there, J. K can be completed once I is completed, so let's complete I, number 7. Let's have K here, probably have to redraw this in a second. And L can be completed once J is completed, so L. Okay, now I've just got 3 arcs now that are just pointing off into nothingness. I need to join those up now into a sync node, because at this point the process is completed. So I'm just going to redraw L up here like this, and I'll redraw H down to sort of join those two. Whoops, I told you straight lines only, didn't I? So I better try and do that nicely. H. Okay, and that will be node number 9. So that is my activity network for this process. I'd like you now to look at the MyMaths homework that I've set on this before you move on to the before exercise 8A from the textbook. So what you should do now is go through your notes, just run through them, obviously make your own, fill in your tables and make your own notes on this as you see fit, then complete the MyMaths and then work on exercise 8A. Okay.